All right, time for our look at our final functional group, which are esters. Esters are the product of the reaction between a carboxylic acid and an alcohol. Okay, to name them, you identify the part that was the alcohol, and that gets labeled as a branch. Then you identify the part that was a carboxylic acid, and that gets named as the root with the suffix O8. All right, so I'm going to draw a very simple molecule in terms of an ester right here. So there's 3 carbons in what's going to be the main chain, and this, what's circled in red, is known as the ester functionality. Okay, esters are second on the priority list, and for purposes of our class, will never be paired with a carboxylic acid. So the carbon that contains the double bond to the oxygen is always carbon 1 in the main chain. All right, that's a rule that we won't vary on you. It's a helpful tip for right now. Okay, this is the part of the molecule highlighted in red there with the brace. This is what was an acid. I'll show you how that comes to be in a little while. Okay, but it's the part of the molecule that has the carbon with the double bond to the oxygen. That's the part that was the acid. Now, circled in purple is the branch that came from an alcohol. All right, and when the acid and the alcohol react, they leave behind this ester functionality, which is circled in red. So it basically links 2 chains. So I label the branch as methyl because there's 1 carbon in that little branch. There's 3 carbons in the main chain, so it's propan, and I use the suffix O8. So this is methyl propanoate. Okay, so now how would we make this? All right, I've talked about the part that comes from an acid and the part that comes from an alcohol. So I'm going to illustrate the reaction now. I'll try to do this and label as much as I can. So this is methanol, so a 1 carbon chain with an OH group. So meth for 1 carbon and all for the alcohol, so that's methanol. Now let's draw a 3 carbon chain with a carboxylic acid. So this would be propanoic acid. All right, propan for 3 carbons and oic acid for the carboxyl group there. So now what happens is I'm going to circle in green. You'll recognize this little molecule. All right, H2O is basically ripped out of the 2 starting molecules. This is known as dehydration synthesis. Any of you that have been through Bio 12 have seen this already. We would label this as an esterification reaction, so it produces an ester. So when water is removed from the alcohol carboxylic acid combination, what's left behind is a molecule that has joined together those 2 carbon chains. So you can see the methyl part that came from the alcohol and the propanoate part, which came from the carboxylic acid. You can see methyl propanoate. Okay, with the ester functional group stuck right there in the middle. Okay, now let's try to come up with, a complicated substituted ester, and I'll show you how to go about naming the various parts. All right, so I'm going to put 4 carbons in the main chain. All right, you can identify the main chain as the chain that contains the carbon with the double bond to the oxygen. All right, we'll make a branched chain down at the bottom here on the right. Okay, we'll substitute with some fluorines, a hydroxyl, put a bromine up on the main chain as well. And let's account for all the various parts of this. All right, so here's the ester functionality. Okay, we know the carbon with the double bond to the oxygen there is going to be carbon 1. So that carbon that has the double bond to the oxygen and the single bond to the other oxygen, that specific carbon is carbon 1. 2, 3, 4. So there's the main chain. The main chain is a bute chain, all right, because there are 4 carbons. This is the part that came from the carboxylic acid, or that would have come from a carboxylic acid. All right, it's substituted at carbon 3 with a bromine, so it's a bromo at carbon 3. Now, this is a branch on the main chain, which becomes important in terms of order in a minute. Now I have to deal with the branch part of the ester, the part that came from the alcohol. So I've got some fluorines down there and a hydroxy, so I have to account for these as well. Again, this is the part of the ester molecule that would have come from an alcohol. But it's substituted, all right? So there's the hydroxy and all those fluorines, so I need to account for them in the name. So here's how we go about doing that. Start by naming the part of the molecule that would have come from the alcohol. So this I'm going to be 3,3,3-trifluoro, okay, because carbon 1 of that little alcohol branch is the one that's attached to the ester group. So farthest right on your screen. Carbon 2, farthest left on your screen, the third carbon is the fluoro. So 2-hydroxypropyl, 3,3,3-trifluoro, 2-hydroxypropyl. This is the alcohol branch, if you will, of the ester, and I put that in a set of brackets. Now it's time to account for the bromine branch on the main chain, so -3-bromo, because the bromo occurs at carbon 3 on the main chain. Butan, because it's a 4-carbon main chain. O8. Okay, the O8 for the ester functionality. So 3,3,3-trifluoro, 2-hydroxypropyl, 3-bromo-butanoate is the full name of this thing.